Hello everyone and welcome back to Java Foundations. We're moving on to section 1.3 and this is where we get our hands dirty. We're finally going to set up Java on our systems, which is crucial to begin coding. In this lesson, we'll cover a few key objectives. Understand the difference between JDK and JRE, the difference between .java and .class files, describe the purpose of an integrated development environment, IDE, and learn how to add an existing .java file into a Java project. Let's think about how computers actually understand what we want to do. A computer system, or usually a computer program, is simply a set of instructions that runs on a digital device. However, at the machine level, this program consists of binary instructions. So it can be difficult to translate it to the ones and zeros directly. This is where high-level programming comes in. Most programs are written in human-readable code. However, we need compilers to translate the high-level code to machine code to each of their specific operating system and binaries. Programs written in most languages usually require numerous modifications to run on more than one type of computing platform. Computing platform is a combination of a CPU and an operating system. That's because most languages require you to write code specific to the underlying platform. Popular programming languages like C and C++ require programmers to compile and link their programs, resulting in an executable program that's unique to a platform. A compiler is an application that converts a program that you write in a CPU-specific code called machine code. These platform-specific files, which are binary, are often combined with other files, such as libraries of pre-written code. And a linker creates a platform-dependent program called an executable that an end user can execute. Unlike C and C++, the Java programming language is platform independent. The image illustrates how a compiler creates a binary file. In this process, to make sure we get platform-specific executions, it needs to be linked to their respective operating systems. This allows for the executables to take advantage of the benefits provided by each respective operating system. The image illustrates how a binary file is linked with libraries to create a platform-dependent executable. What we end up with this is programs that depend on a specific platform. The image illustrates how platform-dependent executables can execute only on one platform. Now, here is where Java does things differently. It is designed to be platform-independent. This means you write the code once, and it can run on any system with Java installed. The first step is to take the Java and convert it to bytecode using Java compiler. A Java program can run on several different CPUs and operating system combinations, such as the Solaris OS on a Spark chip, Mac OS X on an Intel chip, and Microsoft Windows on an Intel chip, usually with few or no modifications. As illustrated in the image, Java programs are compiled with a Java compiler. The resulting format of a compiled Java program is platform-independent Java bytecode instead of CPU-specific machine code. The created bytecode is interpreted by a bytecode interpreter called the Java Virtual Machine, JVM. A virtual machine is a platform-specific program that understands platform-independent bytecode and can execute it on a particular platform. For this reason, the Java programming language is often referred to as an interpreted language. And Java technology programs are said to be portable or executable on any platform. As an example, another interpreted language is Perl. This bytecode isn't machine code directly. Instead, it runs inside something called the Java Virtual Machine, JVM. The JVM acts as an interpreter. The JVM is like an universal translator that understands the bytecode and executes it on the underlying operating system. The image illustrates a Java bytecode file executing on several platforms where a Java runtime environment exists. A virtual machine gets its name because it is a piece of software that runs code, a task usually accomplished by the CPU or hardware machine. For Java programs to be platform independent, the JVM is required on every platform where your program will run. The JVM is responsible for interpreting Java code, loading Java classes, and executing Java programs. However, a Java program needs more than just a JVM to execute. It also needs a set of standard Java class libraries for the platform. Java class libraries are libraries of pre-written code that can be combined with the code that you write to create robust applications. Combined, the JVM software and Java class libraries are referred to as the Java Runtime Environment, JRE. JREs are available from Oracle for many common platforms. And that brings us to the Java Runtime Environment, or JRE. The JRE includes everything needed to run Java programs. Think of it as the environment that allows you to execute a Java program, regardless of your operating system. It consists of Java Virtual Machine, JVM, and Java class libraries. As we covered, it needs to read the bytecode, which has an extension of .class, to run the bytecode in a JVM. Now, what if you want to create Java programs? That's where the Java Development Kit, or JDK, comes in. The JDK contains everything in the JRE plus additional tools needed for development, mainly the Java compiler. As shown in the graphic, we need the JDK to compile the bytecode. To make our lives easier, we typically use an integrated development environment, or IDE. An IDE combines a text editor, a compiler, a debugger, and other tools into one convenient package. Eclipse, Alice, Greenfoot, IntelliJ are examples of IDEs. When you're making a Java program, you will use a Java IDE and go from the Java, an extension of .java code, and convert it to a class using JDK. From there, you can use JRE to run the Java program. The diagram shows what happens when you compile and run a Java program. You have an idea for a Java program. The Java code is written in a Java IDE, and the file has a .java extension. This is called the Java source code. The compiler component of the JDK compiles the source code into a bytecode file with a .class extension. This is called a Java class. The JVM component of the JRE runs the Java class. This is your Java program. Now, celebrate triumphantly when your code works, because most of the time it won't work. This diagram oversimplifies the debugging aspect of the development. You will be supplied .java files to work from. To do this, simply refer to IDE's documentation for instructions on how to do this. Let's recap. We now know that Java code must be compiled into machine code. It's platform independent. A Java IDE can write the source code. JDK will compile the bytecode. Finally, the bytecode will run in a JRE within the JVM. Congratulations on finishing the module. We understand how to set everything up. Thank you.